if my slides click. Okay, so first, like, what the heck is an AutoRigger? Because I'm sure y'all like hear it all the time, but what does it really do, and how is it practical? An AutoRigger is a system of code designed to automate the repetitive portions of rigging. I think that it's important that it specifies the repetitive portions of rigging, because I think there's a lot of misconceptions. So what an AutoRigger is not is a super smart AI that's going to steal your job, a cop-out or shortcut to rigging, or an all-in-one solution to technical problems. And that's where it goes back to it's speeds up the repetitive processes. Like once you know how to make an IK-FK switch, you don't have to do it 6 billion times for every character that you rig. It's nice to be able to have that set up and ready to go and just be able to add it in and start thinking more about things that relate to the character and how everything's going to work together. So why would you use an AutoRigger as compared to making everything manually? I like to think of rigging as like a balance between technical and artistic parts. So you have to like figure out how everything's going to move and set up your constraints and everything that goes on behind the scenes that the animators don't appreciate at all, but makes your rig really cool. And then you also have to figure out how to make it look nice. And that's the end product, is that it has to look nice in your renders and in the animation and work well for the animators. So it's going to greatly speed up your workflow, and it gives you more time to focus on the artistic side of rigging, which again is what I think most people would consider to be more important, since no one's going to get to see how cool your setup is behind the scenes when they're watching a Disney movie. You know, they just see that the character looks cool, and focus on the performance. So another key thing is that iteration equals quality. The more time you spend in like figure out and tweak things, the better your rig is going to be. If you go in and you like really roughly lay out joints, and you start moving stuff and you build your whole rig and then you realize that your shoulder placement's wrong, it's going to be really hard to go back in and fix that. But if you can easily just adjust your shoulder placement of that joint, it's going to make your rig better overall. So AutoRiggers are going to let you do a couple of things that are really, really beneficial and help speed you up a lot. It's going to let you adjust your joint placement on the fly. So like if, like with the shoulder, if you really didn't like where your shoulder was bending from, you can move that joint down a little bit, reorient your joints, and then you're set. Or like in fingers, because that's always something that like I have trouble with, is getting joint placement right for fingers. You can try a couple things out and tweak it until you get one that looks like really, really solid. There's less room for user error. I know that I make mistakes all the time, especially when I'm rigging and doing complicated things. And I've been doing it for like sitting at my desk for a while. I start to connect things and like do stuff that probably isn't that smart, and make lots of silly mistakes. But the nice thing about an auto rig is that once you have it done, it's done, and you always know how that arm is going to work. Also model updates, because even though you get a model and it's super final, it's never usually final, and you'll probably have to update your rig at some point because the animators get it and it starts moving around and you realize that the character's head's too big or something silly. And you have to go back in and adjust your rig, and it can be a real pain in the ass, but it makes it really easy to do with an auto rig. You can update your setup easily across multiple rigs. So I recently, as like a personal example, in my auto rig, I'd used an IK spline for bendy and stretchy limbs. And I realized that that really wasn't working as well as I wanted it to. So I could go back into my code, I could change a couple things, and write something to use ribbons instead. And then I could rebuild all of the rigs for a short film in a couple hours with the updated rigs that didn't have issues. 5, you can spend more time on doing deformations and focusing on, again, like what makes that character and how they're going to move and deform. And then last, and what I think, or at least this was for me, what was the most important is that it doesn't get boring. Because after I'd done like a reverse foot a couple times, I was like, okay, I don't think that I ever want to do that ever again manually. Because it's like the same thing over and over and over. And I would rather focus on things that are more fun and challenging. So using an AutoRigger and how to incorporate one into your workflow. There are a ton of options that are free, and I'm sure you've heard of most of them. So Advanced Skeleton is like what SCAD uses. There's one called MGear, which is really nice. A lot of like small studios use that. There's a tool called RapidRig Modular, which is pretty fancy. And then there's another one called Perseus AutoRig, which is free. And you've probably seen the demo reel of the guy that did this. It's really nice looking, and he has a really good demo reel. And then there are tons of other ones like all over the place. But or you can write your own, which I think is probably your better option. But if you're going to use an AutoRigger, you need to be familiar with the system and be able to debug issues when they come up, because there will be issues at some point. And if you only know how to use Advanced Skeleton and you don't know how Maya works behind the scenes, it's not going to be helpful for anyone if you can't solve bugs when they pop up. So here are some of the benefits of writing your own auto-rigging system. You'll know it inside and out and be able to like debug and figure out anything as soon as stuff starts happening, because you will spend a long time working on it. You can easily expand on your system. If something's not working, it's a lot easier to go in and adjust your code versus someone else's code. Especially stuff like Advanced Skeleton that's set up in like a really wonky way where it's like all one big long mel file. And then the rig is going to be exactly how you like things set up. So it's going to have like whatever cool fun features you want to add in, exactly how you want them to work. And then it's also a good portfolio booster. It shows that you know how to code and you can think through problems well, and that you can do more than just click buttons and follow tutorials and stuff. So according to Steve Jobs, the main man, he said everyone in this country should learn to program because it teaches you how to think. And I think the same thing's true for programming in AutoRig and Maya, where it really shows you what's going on behind the scenes of Maya and helps you think about things in a different way. So now I'm going to try to do a live demo of how I have mine set up and answer any questions that you guys have so that we can get started with something cool. Do you guys have any questions so far? Is there anything in specific you want to talk about with like AutoRig stuff?
I see you just have a Python open in like a whole, like in the actual Python program, it looks like.
Oh yeah, this is a plugin for Maya. It's called Charcoal Editor. It's so nice. It like opens up from the regular script editor, but it has like a bunch more features, and it's really, really cool.
What are some of the features?
It has like autocomplete built into it, so like import.
Huge lifesaver.
Oops, and then here's like all of the modules in my AutoRig where you can go in. It generally, I think, works a lot better. It also has, let's make something stupid. So we'll put like a queue in here. And then if we run it, it color codes your errors and warnings and stuff, which sounds like it's not that helpful, but it's really, really helpful. It has a bunch of cool stuff. I would highly recommend it. It's a couple bucks, I think. It's a little bit on the expensive side, but if you spend a lot of time like coding, I think it's definitely worth it. So, okay. I'm gonna get into AutoRiggers.
Over here.
Oh, hello. Okay. So when you get started, I have like a ton of stuff in here now because it's kind of a mess. But you're gonna want to decide how you want to break up the project. So each like Python, it's built off of different files and they call those modules, and you want to structure your modules in a way that makes sense. So the way that I have it set up is I have utilities, which is like some stuff that generally I need across all of my different rig parts. I have a UI, which has just like some icons and stuff for now. I haven't built like a proper UI. I have testing, which just has like an example script so that I can make sure that things are running the way that they need to. And then the like meat and potatoes of the AutoRig are your modules. So each like body part is built up into a different module. And then there's also sub modules, which are like building an FK chain or a joint chain or a control. And that's stuff that you're going to use all over in your rig. And the reason that you want to break it up like this is so you can make adjustments to, like, say, to your FK chain code. And then it's going to apply to all of your body parts that use an FK chain. Like if I wanted to use, instead of a parent constraint, use an orient constraint or whatever, I could change that in here and say that I don't want to constrain the translate. And so now whenever I build anything with an FK chain, it'll only constrain the rotation. But I don't, because that's kind of useful. So you want to think about how much you can reuse things. One of the things that I learned when I was researching is there's a principle in coding called the drive principle, where it's don't repeat yourself. So anytime that you've written something twice, even if it's like anything more than 2 or 3 lines, you're going to want to make it a separate definition and put it in a utility somewhere. So I think, is everything clear so far about like how modules kind of work?
I think we get the point.
Okay, cool. If there's anything in specific that you guys want me to show too, I can do that. But okay, so we'll take a look at the joint chain module first, because that's kind of a simple one. And it shows how everything is set up. So what's really beneficial when doing stuff like this is to use classes. I don't know where I learned about them, but I learned about them somewhere, and they're like probably the coolest thing in Python that I've found. So essentially what a class is it's like a group of functions, but you can save all of your variables in them. So if we were to, I'm sorry if this gets like too boring and Python-y. Dot core. Sorry, I'm trying to type on my smaller keyboard. And we'll make a class called example class. And every class you're going to have a definition called init, and it's going to inherit self. Self just means that it's a function within that class. So now we could go in and define a variable. So like say variable equals 3. And in this, we're going to say self dot variable equals 3. Cool. So then we could have a function like math or def do math. And then we'll make one called multiplier.
You're coming. You're coming, right?
Okay. And the reason that I'm storing these where it says self dot whatever, multiplier variable, oops, is so that I can get just this variable later from like only Python. So here we'll do
let's do that.
Print self dot variable times self dot multiplier. Cool. And if we run this class, it's not going to do anything. But now what's kind of nice is later along we could say like I want to get my example class, and we'll make
Oh,
instance of it. So we'll say class equals an instance of this, and we could say our variable is going to be 3, and our multiplier is going to be 2. And if we run that line, it's not going to do anything. But now we could say example class dot do math, and it's going to run this function here. But the super cool thing is that later along I could say example class dot variable, oops. And if it's just one line, it'll return the variable that we had. So you can share variables and stuff across like multiple different definitions and functions without making something really complicated and reusable. Like when I first started with Python, I had everything in separate definitions, and it would like return something, and then I would take that function and like plug it into something else, and it was very like messy and sloppy, and like a very convoluted way of working. But the nice thing about this is that you have variables that you can build on and work across
my berries.
multiple files. So the way that it's set up is for every joint chain that you're ever going to want to create ever, you're going to have a base name, it's going to have a side, and then preset names. And preset names are just like if you're doing an arm, it's going to say like for the shoulder joint, it'll be shoulder. For the elbow, it'll say elbow. For the wrist, it'll say wrist. And then once we're done, we're going to want to create an empty list with a chain, or called chain, that just has our joint chain. And so from list, it's a definition. It just takes in some guides, and then you can control whether or not you want anything oriented, mirrored, and how you want the orientation of the joints. And it'll go through and build your joint chain and set everything up. But the cool thing about that is for things like an arm, I have a function here where I want to build an FK chain, and I just pass in those same variables. So I want it to be called the base name of my arm function. Ooh, is this the wrong file? No, okay.
It's gonna keep going that way then.
Base name, the side, and then the preset names plus FK, color, and then I can build that chain. So if I were to run the code to build an arm, it's going to loop through and build the joint chain, and then it's going to run my FK chain, submodule, and then the IK chain submodule, and then connect everything together and add like some extra fun stuff in there to make it cool. But so that's all that I would need to do to build an arm, and it's like a fully functioning arm that's going to work and like bend and do everything that's super cool. It has like IK, FK. And if we look in here a little bit more, let me actually copy all of this and go to a new Python tab. So here's the arm. And here are just like some attributes that I want to pass to it. So it's set up in sections. So when I'm building modules, I say I want to create whatever that module is, so an arm, and then I want to build the guides. And the guides are just, they're actually joints that have the joint draw style turned to none and a shape parented to them. So it's a little bit nicer to like work with. But you can go in and place these and get them to fit on your character. And it's nice because you can also like hit D and use that. And so then that's how we want our joints. Then I can build the joints, and it's going to go through and run all of the code to make the FK chain, the IK chain, the like stretchy, the ribbons, and all of that. But now what's kind of neat, And then I didn't talk about this, but build connections is just like to connect your arms to your spine and cool stuff like that. But I could go in and say arms dot IK chain, and it should give me a list. Oh, arm. Sorry, not arms.
I grab water.
Okay, so it returned a link to the class, but if I do chain dot or ikchain dot chain, it's going to give me a list of all of my FK or IK joints in the scene. So if I went and I found this in the outliner, here are my IK joints. So it's a cool way to manage data is with classes. And I would highly, highly recommend if you're going to build an AutoRig to look into those and then work progressively. Do you have any questions so far or anything that I didn't really explain clearly or like want clarified or?
Got it.
Is there anything that you guys want to see? Because I don't want to just talk your ear off about like boring Python stuff.
Let's go that way.
Can you show how maybe you could apply some of your utilities to that arm you just made?
Yeah. So actually, the utilities are built into all of the modules, and they're just like things that I do a lot. So if I look up here for the utilities, I have name utilities, xform utilities, node utilities, hook utilities, meta utilities, and then control utilities. And the utilities are really just like simple little tools. So like control utils it's a lot of like short definitions to do kind of simple things. So to save a script or save a control to a library, the way that I'm building all of the controls is that it saves them as a dictionary. So it just has the degree, the form, the knots, and then just stores the point positions. And it's just like a JSON file with the .control extension because it's fun to make little custom extensions. But so I could like select a control and run the save to lib, and it'll save whatever shape I have selected or shapes to a library, and then I can call that back later. The build control shape just builds a control shape with the name of the file that you want to load in. I shouldn't have closed this window. So like build control shape pin, we'll just find the pin control shape and then build it, and then it'll name it that. Let's do an example. J. So control utils dot build control shape, and we could build. Let's build a
way back.
A sphere. And we'll give it the name example control. And so if we run that, oops, it should make a control with that name in the scene.
Dude.
Oh my gosh, I think I clustered the whole thing. I did. Okay.
Let's do it once.
I'm just going to delete those. Okay. So the control utils just builds a control shape. And then that can be like snapped. So then the like xform utils, I'm going to leave that open for now, actually, because I have a feeling that I'm going to come back to making something. Has some stuff just to like zero out orient, which like makes a group, an offset group above it, and then adds another SDK group if you want that, or a negate group. It has a constraint, and the constraint is just like doing a parent or orient constraint. or scale constraint, I was just a little bit like particular, and I kept getting confused because I also have a matrix constraint definition, and so it would mess me up when I'm like going between matrix constraint and constrain. So I wrote one that's just to constrain two things together. So it just checks to see like if you're saying you want to translate and rotate, then we'll make a parent constraint. If you only want to translate, do a point. If you only want to rotate and orient, and then if you want to scale, then make a scale constraint. And then it just has this little helper function called prune constraint, which takes out, when you make a constraint,
I keep forgetting to grab water.
there are a couple like, oops, and this is just my little like menu of stuff to do faster. Oops. Let's add a little bit of an offset to that.
So I didn't bring the bed.
Okay, that's better. So now we can kind of see that like this
I should have
constrains that.
adopted it for a specific reason.
Hey, can everyone just check that your mic is muted? Sorry to interrupt. Just
Yeah, you can keep going, Mason.
Okay. Sorry. It doesn't look like it was doing what I was hoping would happen, which isn't very cool. Maya, come on. I needed you to cooperate. Okay, let's delete this constraint. Okay, delete. Okay. And constrain, parent constraint. Here we go. Okay. So you see how you get all of these extra connections where it like takes the rotate pivot and plugs it into the rotate pivot over here. And it makes like a little tiny cycle. It's not like a bad cycle. It won't give you a cycle error, but it does slow down your parent constraints just like a teeny tiny bit. So I had written this little part to remove out like the constrain order, the constrain rotate pivot, and the constrain rotate translate connections. So it just breaks these connections whenever I make a not that one here. Whenever I make a constraint. So it makes your constraints just like a teeny tiny bit faster to evaluate. And then the other thing was a matrix constraint, which are super cool, and they're even more lightweight than constraints that are removed with the cycles. But they have a little bit of drawbacks constraining to joints sometimes because of how joint orient works. So that's why I have both in, because sometimes I do get lazy and just use regular constraints. But that's kind of how my utilities work. I also have one to create a twist extractor, which just like calculates the twist based on how much a joint is rotating, and it'll figure out how much it should apply that to like your ribbon setup. So those are kind of how the utilities work. I wanted to show an example of how I would build like a character rig too. And then I think I'm gonna just like take questions or answer stuff if you guys have any. So the way that I go about building something is I have another module. It's probably one of like the simplest but also most important modules in the script, and it's called build session. And all that it does is it looks through, you give it a bunch of modules, and then it has functions that match the name of the functions on like the modules where you build guides, build, and then build connections. So it's going to run a pre-build, but when you say build guides, it's going to get all of your modules in the modules variable, and it's going to build the guides. So it just runs this code that's in each class for every class that you have that you pass to this build session class. It's going to do the same thing for build, except I have a little bit of extra code to make a progress window because it's more fun to watch it like go across in the progress when it's building. But then it just runs the mbuild for each module. And same thing for connections, and then it's going to run a cleanup. I have a couple functions to save and load the whole rig, but I don't use those too often because I like to add and keep flexibility. But once I do a UI, then it'll have that in there. So that's all that it needs to run it. So we'll create a build session and then create all of our classes. So you have to figure out like what you need. So for a biped, you need 2 arms, 2 legs, a spine, a neck, a hand, eyes, and a jaw. I actually don't have the jaw added to my list of modules. And I'm gonna block this code out. So then what it'll do, you create all of your modules. You can say like if you want them to be stretchy, if you want to have twisty bendy. The IK pole vector projection, just because the pole vector gets calculated. There's a cool tutorial I found on how to calculate the position of a pole vector so that it won't snap when you switch from IK to FK. If you guys have ever seen rigs where if you switch the mode, there's like a tiny little shift from going from IK to FK. And it'll figure out where you need to put your pole vector so that the switch is like 100% seamless. And then I have a variable for auto orient, and we'll see what that does. And then this is a hook ref array, so hook reference array. It just tells like what each joint needs to connect to. And then you put it all in a module. So if we run all this stuff, it's not going to do anything. But then if we run our build session, .build guides, it's going to run a bunch of stuff and make a really, really messy looking scene. And if we look at this in the outliner, it's going to be all of our guides. So here's like the leg, the knee, the hand. And you can go in and like place all of this stuff and fit it to your character. And I have just like a couple shelf buttons to do stuff like mirroring it. So let's get the arm and mirror. So you can go through and place all of it. I actually have a guided position file where you can, let's save the student license. It's just like a path and then it loads the guides. It's just a JSON file that stores the position, scale, and rotation, and then applies the scale, position, rotation to what we're looking at. So I don't think that the jaw module is actually set up in here. So we'll see what happens when we build it. But now we have all of our guides. We have them placed to fit the character. And then we can say build. And it's going to go through and build all of the parts. And then the last one's the eyes. And I'm getting these errors. Oh, actually, I do have an error. Okay. I have a pretty bad error. Sorry, ignore that. We're going to try it again just without the jaw. Because I didn't hook up the jaw correctly. So now let's try to build it again. And then that last step, it just loads all of I called it the control UI, like the control user interface. Control curves from a file so that it works a little bit better. And you can shape it to the character more. But then the rig is all set up and done. You can do everything you need to do. Oops. Here's like the FK. Oh, and I'll show the IK-FK switch stuff. So if that's the IK or the FK, and then I switch to IK, it doesn't shift the joints at all. Or you know how sometimes if you make a joint chain, there's my very crappy joint chain. And let's create an IK handle. Oops, sorry. Create an IK handle, and it doesn't do anything there. But then once we make a shapes locator. a locator and we put it kind of where we think it should go for the pole vector, we can constrain pole vector. And then if you turn it on and off, there should be a little bit of like a snap that happens. Actually, maybe this is put in the right place. Do you guys know what I'm talking about when I'm talking about the pop?
Yes.
I can put a link to the tutorial for that in a chat somewhere because it's super cool. So now we'll do pole vector, and I think that it did it that time. Maybe not. Anyway, that just gets rid of that. So the last cool thing in the AutoRig is it's just a module to save and load skin weights. So it's going to look for a file that's called all body skin pack. And that's just a dictionary with a bunch of paths to different skin weight files. And it'll load all of your skin weights in so that you can rebuild, like work on the character, save the skin weights out, and then go back in and like refine your joint placement. And then you can rebuild the skeleton and it'll keep your skinning. That's like my #1 tip, I'd say, to anyone like working in a production on rigging is working with referencing a model is a huge pain in the ass, because even though the model is going to change, keeping a reference to it gives you a lot of space for stuff to get like dirty in the file and kind of messy, even though the model is going to be updated. What I'd highly recommend is getting a tool to save out the skin weights to an external file and then load them back in. It's going to make it a lot smoother getting edits from a model. But I think that's everything for me, unless you guys have questions or like want me to go deeper into anything. I'm happy to like talk about how anything's done in more detail. And again, this isn't like the one and only way to write an AutoRig or how to set it up. I just wanted to give you like a little bit of how I set mine up to hopefully like get your brains started thinking about how to go about doing it. And if you have any questions, like you start working on your own, feel free to like ask me and I'm happy to help, or anyone in the Rigging Union Discord, because everyone's super friendly. Did I make everything too confusing? If I did, that's okay.
I think it was all right.
Okay.
I really liked it. I like how you went like really modular with like using a lot of different definitions, and that's something I could probably work in a little bit more to my auto rig as well. That's partially modular, but I mean after seeing yours, it's like really I'm realizing there's a lot there I could go. So yeah, really thanks for sharing. It's really informative.
Yeah, for sure. I would be happy to. Eventually I want to make this like public, but I don't think it's at a point where I can do that yet. There's a lot of like things that are really buggy. And it's still all in like through Python. I don't have a nice UI for it, which I want to do. But it looks very overwhelming, but once you get into it, it's not too bad, because once you've done one module, it's basically the same thing. Where like if I look at the arm and then the leg, and I can dock them side by side. Okay, here we go. So it's the same up here. It has the same variables. The setup is the same. The build guide is pretty much the same. The build is a little bit different because this has a clavicle and this one doesn't. But it still has the same stuff like add stretchy, and a lot of the code you can just like copy and paste over with a couple like minor changes. It has the same functions to like save the module, add stretchy IK. A lot of it's the same. It just goes to different joints. And even like the spine. The spine's probably one of the simplest ones that I have. I don't have a very complicated spine rig. The arms and legs are much more complicated. But like it just builds an FK spine, an IK spine, and then blends the two together. Down here, I have a function to add stretchy where it just like figures out the length of the curve, and I think that's pretty straightforward. And then adds like the advanced twist. I probably need to redo it because it's not the best way to go about doing a spine. But like they don't have to be complicated and really intimidating modules. It could be something simple. And like I think Brandon said earlier, anytime you do something in Maya, it's going to make or show you what it was. So this was a polycube. And then if we like make a constraint for it, it shows you parent constraint. Like that's basically like what I did when I was writing this is I'd go through and like make the rig and then figure out all of my steps that I needed to do to set it up. Oh, actually, I do have one other recommendation for anyone that's interested in doing this. I would super recommend using PyMel instead of like Maya commands. I don't know. Are you guys familiar with PyMel?
Yeah.
PyMel is so cool. It's going to save your butt so many times. Basically, if for anyone that's like not familiar with it, it's the same thing as Maya commands, except it's object oriented. So the same thing that I was talking about with classes where you can like save variables and use them in other places, it does that with like regular Maya stuff, which is pretty handy. Oops.
I was using PyMel for a little bit. But the issue I had with it is it just takes so long to load up. So every time I wanted to reiterate, I had to like 5 seconds or so to like just to let my thing run up to test one thing, and it kind of slowed me down. So I found a way to like go about the object-oriented thing with Maya commands using pickling.
Oh, cool.
Yeah, but I mean, yeah, like some of the features for PyMel definitely were really cool. It's just the time thing.
Mm-hmm. Yeah. That's for sure. Like one of the things I saw, have you guys seen or heard about Jeremy Ernst or seen his? Yeah, he did a talk, I think it was at SCAD like a couple years ago about his auto rig that he worked on at excuse me?
Epic.
Yeah. And he said that it was really slow, and all that he did to speed it up was he put all of the modules in like a single file, so that you only had to import one file instead of like an arm, a spine, a leg, and it sped it up. So like there's all sorts of weird stuff that you can do to make your auto rigs work faster, and like be creative about it, I guess. Like using pickling, like that was a really smart way to get around it. I was just kind of decided it was worth the wait, and I put up with it to load PyMel. But
is anyone like going off of what you earlier about like just watching the script output? There's a plugin called Easy Mel to Py, where you can actually just copy your Maya command or the script editor output and then paste it in, and it converts it to Python. So that was really helpful for me.
oh, that's so cool! I didn't know that that was the thing. I'm gonna have to look at that.
It's really cool. It's a big time saver.
I'm gonna write that down now.
It's a little buggy to set up though, sometimes. At least I had problems setting it up, but then once you get it working, it's cool.
Yeah.
Cool. I'm gonna have to check that out. That's exciting. Because I always do it the like super long way where I copy the name and then like go paste it in the docs and to get the right flags and stuff.
I'm not sure if he had. I think it was free, but I'm
No, it's
not
free.
totally. Okay, cool.
I'm pretty sure it's free, yeah.
Okay.
Nice.
Cool.
Well, it converts it to PyMel, but it still gives you the commands that you need.
Yeah, if you just change the PM to my commands, then it usually most of the time works. There's some rare cases where you might have to like figure out a different way of writing it just because my commands.
That's so cool. Oh, that's another thing that I like looked at a bunch when I was first getting started is this website, the Wester Banks thing. And I have a little bookmark. Excuse me, sorry. Of like cool stuff that I found and then just like added in as I go. Like this was a cool way I thought of doing like space switching. Oops. Apparently now it's a private website. But like I'm not smart enough to figure out most of the things that I did on my own, so I just look for tutorials and examples and figure out how to connect different things together. And the Wester Banks thing is a really good resource because he just finds like all sorts of articles from all over the place and puts them in one spot.